Okay, so in this video we're going to attempt the 2019 SPM At Maths Paper 2, question 13. It's a geometrical question, a question on geometry. Solution by drawings not accepted, blah blah blah. You got a quadrilateral such that AC and BD are straight lines. Okay, straightforward. It is given that the area of ABC is 6 centimeters square. That's a small little triangle in there. And ABC is obtuse. Sure, find angle ABC. Okay, that's a simple, straightforward application of the sine rule. So if you remember, that's section A, question 13, subsection 1. Right, so if you remember, area is equal to half, let's call it AB sine C, something like that. So in this case, it's strictly speaking a C sine B, right? Or half of AC sine B, right? So area we're given as 6, so we have 6 equals to half of length A is, oops, sorry about that. Where have our questions gone? Okay, so length A is 3.5, length C is 4. So we've got 3.5 into 4 and sine B equals that. So let's evaluate all of that. We get sine B equal to, what do we have? 12 divided by 4, which is 3. 3 divided 3.5. Yeah, what an ugly number. 3.5, that's 6 over 7, I think. Is that right? So we have 3 over 7 times 2, and that's 6 over 7. Right. So B is obviously inverse sine of 6 over 7. And if you take out your trusty calculator, here we go. Okay. And we have, what do we have? 6 over 7. Inverse sine, that gives you 58.99, almost 59. You're given that, of course, the angle is obtuse, right? So this is the complementary angle plus 90 degrees, and whoa, 180 plus another 90. So the answer is about 121.003, I guess. Okay, which is approximately 121.003 degrees. Okay, done. So for question A, subsection 2, to find the length of AC in centimeters, there's a few ways of doing this. One way is to use Heron's law. You know the area of the triangle. You can compute the third side using the existing two sides, or you can use the cosine rule, which uses the included angle. Alright, so the cosine rule states that length AC, which is also known as B, square is equals to A square plus C square minus 2AB cos C. Hang on, sorry, 2AC cos B. Okay, that wasn't very well done, so let's do that again. Minus 2AC cosine B. Alright? C squared. Let's just eliminate that. Okay. Not very pretty, but never mind. Okay, so B is obviously equal to the square root of A squared, which is 3.5 squared. Well, let's do C squared plus A squared. Doesn't matter. Plus this one squared minus 2AC, which is 2A, and then C, and cos B. Alright, now cosine B is the tricky one. We know sine B, obviously. That's 6 over 7 from the previous results. Okay, but you notice that cosine B, this being an obtuse angle, should be a negative number. So while we know that cos squared theta is equal to 1 minus sine squared theta, you have to always be really careful about cos theta. Is it the plus or is it the minus root, right? And since we know this is an obtuse angle, it should be the negative root, right? So we're just going to convert that to negative and take 1 minus sine squared b. Alright, so whack that all into the calculator and let's give this a go. 6 divided by 7 equals, square that, subtract that from 1, that gives you that, take the square root, then you multiply that by 2, by 3.5 and by 4, equate that, and then add that to 3.5 squared and to 4 squared, all of that, and you take the square root, that gives you 6.53 something. Okay, well, that number over there. Okay, so there you go. And finally, let's do section 3, which is to find angle BAC. Now, angle BAC can be found in, I guess, several ways. Simplest way is again to use the sine law. So that's section 3. We've got half sine angle BAC is equal to the area divided by the first side times the length b, right, which was that ugly 6.5, yeah, whatever number that down there. So therefore BAC is inverse sine of 12 divided by 4 times that b, and so substituting in b, then we have angle BAC is equals to where was my b? That was 832, wasn't it? We took the square root of that. So 832 plus 56.5. 56.5 equals that. Divide that by 2. Hang on. And we take the square root. Whoa. Let's do that again. 832 square root. Whoa. 832 square root. Okay. Plus 56.5 equals that. Divide that by 2. That gives you 42.67. Take that square root, and that's your ugly number. Alright, so 4 times of b, so times 4 equals that. Take the reciprocal and multiply that by 12. That gives 0.45, and we do an inverse sine, that gives you an angle of 27.338. 0.33, what are we doing? 3386, let's call it 339 then. Approximately degrees. Okay, and let's eyeball the diagram. Yeah, that looks like BAC, that looks like it could be 27. That makes a lot of sense. So that's good. So that's section 3 done. Right, so part B, given that BD is 7.3, that's 7.3 cm, and BCD is a 90-degree angle, which is that. Calculate the area of ACD, right? Big triangle right there. Okay, well, let's start with finding out CD, and you can find out CD simply by the Pythagoras theorem. That's pretty straightforward. We know AC, which was that 6.5 centimeter whatever number, that pretty ugly number. We can find out this angle, which is just 180 different, 90 degrees different from that. Which you can then compute from these two other angles, which you already have. And there we go, we can apply the sine rule again, right? Okay, so let's try this. Option B. So the area of ACD is equals to half of CD times AC times sine of the included angle, which is ACD. Alright, let's have a look. So that's half of, now CD of course is just 7.3, 1.3 squared minus 3.5 squared, which you already know, that's CD, and AC was what we termed the number B, which was that number that we found earlier. Okay, and sine of ACD, right? Sine of ACD is simply cos of ACB. So let's change that to cos of ACB, right? Which is, of course, cos of 180 degrees minus that angle and that angle. Minus, what was that? I think it was 1 to 1.003 roughly, minus the other angle, which was, where were we, approximately 27.338, something like that. Alright, half of that square root times that number, which was about 6.5 thereabouts, times that. Right, so if you punch all of that into your calculator, you'll get the lovely number of approximately 18.35 centimeters square. Alright, let's do a bit of an eyeball check. That's 6, and we're claiming that is about 3 times that. Yeah, looks like maybe it's correct. So we'll leave it at that. Don't really have much time. Right, so that's question number 13 done.